Okay, so quite a nice question here. Determine the dihedral angle between surfaces ADB and ADC. Now we're given a tetrahedron here, so we just need to identify the two surfaces. So ADB is this one here, and ADC, which is this one here. So we want to find the dihedral angle of these. First off, we need to find the line of intersection. Now, given this, AD is our LOI. AD is parallel to our XY line here, so that means this is the true length of our LOI in elevation. So if we look along this, we should see both planes as edge views. Boom. Draw your x2, y2. I'm going to draw a true point A this time, just so I have enough room, because I haven't checked the mark scheme for this. So here's my x2, y2. I'm going to be projecting down this way, which means I'm coming from elevation down to plan, which means I need to take my measurements from my plan. To make this a little bit more convenient, I'm going to create up a datum line, just to save some room. Not totally necessary, I don't think. Label it my DL. So that means point B is going to be on that line. I forgot to bring down point B. Actually, I don't think this is going to fit. Let me just double check that. I know, will fit. Yes. So, I know what they have done. So instead of bringing point B, so as you can see, it's going to end up over here. If we take another vertical line here, so if I join A to A, I'll get a nice vertical line. But if I just say pick this point here and come up, I can just use these 2 points to find a point on that plane. So what that means is, instead of taking my measurements from B or C, I can take my measurements from these points here. So what I'm going to do is I'm going to project down this line here, kind of a curveball there really. And then what I'm going to do is I'm going to measure from my datum line down to here. So I'm going to label that P, Q, and then A obviously, and D. But A and D will be the exact same. So first off, I'll start with AD. That will give us a point. So AD from my XY line there. AD. Now I'm going to take point P, take the measurement from my datum line, from my x2, y2 to there. That's my point P now. And then the same for Q. Hopefully you can see this. Yep. And step that off then as well. If we join it back, A to D, AD to P, Q. There we go, we have our dihedral angle. Don't understand. So yeah, just not enough room, so we could do it that way. You could have done it the traditional way again, look perpendicular or whatever and do it all that way, but this, it was set up nicely to do it that way. Just a little bit awkward the way we didn't have much room here, probably just trying to test to see if you would remember to do this. I just figured might have messed it up, but yeah, nice little curveball there in the mock. Next one here, draw the projections of an inscribed sphere which is tangential to all surfaces of the tetrahedron. So to find an inscribed sphere, you need to be able to find two surfaces of your tetrahedron that are as edge views. Now we're looking at two edge views here, so we're looking at the edge view of DC CB and the edge view of ABC, which is on the ground. So this is an edge view here, and this is an edge view here of a whole face, whereas this is a line of intersection, this line here. So we can see this whole face here has one edge, and the whole bottom face we can see as one edge. It's the same then as normal. Putting a sphere in, that's going to be tangential to this, and it's also going to be directly below the apex. So first off, if we join D to D, we know that our sphere is going to be in the center because it's going to be equidistant from the tetrahedron. So boom, it's going to be somewhere along there, and it's also going to be equidistant from each of these faces. So if we bisect this angle, project up a line, we will find the center point. So I'm going to just swing a nice big arc again, swing another one, project through. We now have the center point for our sphere, taking the distance from the center point to the ground, to the XY line. There we go. Then all we need to do is move it down to plan. Oh, sure. Double check that's still the same size. Yep. There we go. Done. There's your sphere, and it's touching all surfaces because it's directly below the apex. You can see it's tangential here and here, but it's also tangential to the far side. So if you imagine ADC, or ADC here is the same as ABD basically. So we have it touching the base, CDB or BDC, whatever you want to call it, which means it then needs to touch all of these because the tetrahedron is the same distance in every orientation. So every side in a tetrahedron is the same length. Okay, moving on.